Hey y'all. Today's objective is dilations and the effect that dilations have on area and perimeter. So quick review about dilations, perimeter, and area. Dilation is an enlargement or a shrink of an object, a figure. And we worked with dilations, and you usually have a scale factor, and that scale factor is going to either tell you it's an enlargement, a stretch, if the scale factor is greater than 1, or if the scale factor is less than 1, it's going to get smaller, it's a shrink. The figures are similar. They are not congruent, but after dilation, the figures are similar. So this is a shrink or a stretch. The perimeter is the distance around the figure. So the distance around the figure. And our units are just going to be normal inches, centimeters, miles, whatever. The units are just normal units because you're just measuring the distance around the figure. If it's a triangle, you add the 3 sides. If it's a rectangle, you add the 4 sides. If it's a different kind of quadrilateral, then you just add the sides, the distance around. And the area is actually the number of squares that you can fit in, lay across the base, or the number of flat squares that would fit up the base of the shape. I'm not talking about filling the space. I'm talking about the number of square units that would cover the base. So the area for our purposes are going to be units squared, and we're really talking about the number of squares. And so if you had a rectangle and you drew a grid, I know these are terrible lines, but the area would be how many squares cover this space, and the perimeter would be the distance outside. So today we're going to talk about dilations and what happens when you take a shape, a triangle, and you dilate it. What happens to the perimeter and what happens to the area of that dilated shape. So at the end of it, you'll know what's going to happen. Okay, so example 1 is an investigation that I'm going to walk you through. All right. Hopefully you have the note guide because I kind of abbreviated because some of these word problems are really long. A middle school parking lot is 400 feet long and 200 feet wide. The school board wants to double the dimensions. The school board wants to double the dimensions of the parking lot. How will the perimeter and area of the enlarged parking lot compare to the perimeter and area of the current parking lot? So we're assuming this parking lot is a rectangle because it says 400 feet wide and 400 feet long and 200 feet wide. So part A says find the perimeter and area of the current parking lot. So if we take the current parking lot where it is, so we have 400 feet and 200 feet. So the current perimeter and area of the parking lot would be 400, and then we know this is 400. So you would add 400 plus 400 is 800, plus 200 plus 200, so this would be 1,200 feet would be the perimeter. Now remember, the units are just the same. And the area would be 200 times 400. And so that would be 800,000 square feet. 800,000 square feet would be that current area because 200 times 400 is 800. No. I put too many zeros in. 80,000. 1, 2, 3, 4. 1, 2, 3, 4. Oh, goodness. I thought that looked weird. There should be 4 zeros. So 80,000 square feet. Sorry. That is the area and the perimeter of the current parking lot. Now, part B says, sketch a dilation of the parking lot with a new measurement. So it's going to be bigger because it says we're going to double the dimensions. Double means that my scale factor is 2. That's something that we've talked about. Double means the scale factor is 2. Ooh. Which means my new dimensions are 800 and 400 feet. If the parking lot is doubled, something happened to my marker. So the parking lot is doubled, and my new dimensions are 800 and 400. So I need to find the new perimeter and the new area. So the new perimeter, you're going to add 800 plus 800 plus 400 plus 400. And so when you add that, you get 2,400 or 2,400 feet perimeter. So again, I've just added the sides. To find the area, we're going to multiply 800 by 400, and let's just make sure 8 times 4 is 32, and then we have 4 zeros. So 320,000 square feet would be the new area. And then the last part, it says, how do the answers for part A and part C compare to each other in respect to the scale factor? So let's just look for a minute. Originally we had 1,200, 1,200, and now we have 2,400. So can you tell what has happened from 1,200 to 2,400 or 1,200 to 400 in relation to the scale factor? What happened here? And then we had 80,000, and now we're at 320,000. So one way to compare is to divide. Divide. And so I'm just giving you a little hint. Let's take the new one, 2,400 perimeter, over the old one. And 2,400 divided by 1,200 is 2, which is our scale factor. Our scale factor is 2. So when you relate it in terms of the scale factor, the new perimeter is double the old perimeter because the dimensions were double. Now let's look at the area. 320,000 divided by 80,000. That's not going to be double, but can you use mental math and divide? We can cross out all our zeros, and we get 32 divided by 8, which is 4. So the new area is 4 times the original area. The new area is 4 times the original area, and how does that compare to the scale factor? So be thinking about that. I'm going to tell you, but the perimeter was twice as big, and the area was 4 times as big. Okay, let me check the time. All right, example 2, we have a coordinate plane. All right, so on your paper, you have a coordinate plane. On a park map, a picnic area is represented by a rectangle with the coordinates that I put. The park is going to be renovated, and the picnic area will be half its current size. How will this affect the area and perimeter of the picnic? So half. If it's half, that means the scale factor is a half. So our picnic area in this problem is actually getting smaller. The scale factor is a half, so everything is going to be smaller. So what you would do is you would graph the original. So I think I put on there, graph the coordinates, and we're going to find the area and the perimeter. So I'm going to graph these coordinates, 8, 6. Okay, so 8, 6 will be like here, and then 0, 6, and 8, 0. So we have this rectangle. So this is the picnic area. And the perimeter, we would add the sides. So this side is 6 and this is 8. So the area would be 48 units squared. And then the perimeter would be 8 plus 6, because this is 8 and this is 6. So 8 plus 8 is 16, and 16 plus 12 is 28 units. That is the current perimeter and area. Now, part B says draw a dilated shape based on the scale factor. Now, if we want to half the dimensions, that means we half the coordinates. We've talked about this too. 0, 0 would stay the same, and this would be 4, 3, 0, 3, and 4, 0. And I got those because I multiplied all the coordinates by 1/2, the scale factor. And so instead of going all the way out to 8, 6, we would go to 4, 3, 1, 2, 3, so it would be like right here. And then that green rectangle is our new dilated shape. We need to find the perimeter and the area of our new dilated shape. So instead of it being 6 tall, it's 3 and 4. Oh, I think that's backwards. That's backwards. My new area is 12 units squared. And then my new perimeter is 14 units. So there are my new perimeter and my new area. And now the question is, how do those relate to the scale factor? How do the perimeter and the area of the current and the new compare to the scale factor? So again, we're going to divide. So let's divide. For my perimeter, I'm going to divide my new one, 14, by my old one, 28. So 14 was my new perimeter and 28 was my original, because we're comparing the new one to the original, and it reduces to a half, which is the scale factor connection. We want to compare the area. The new area is 12, and the old area was 48. And when we reduce 12 over 48, when we reduce that fraction, we get 1/4. So it's still not 1/2, just like the previous. It's not 1/2. It's not the exact scale factor, but it is related to the scale factor. And I'm going to show you how. Okay? So the key concepts. All right, our key concepts for perimeter and area when in relation with dilation. If you were taking the perimeter and you get the original perimeter and whatever the scale factor is, the new perimeter is the same scale factor. All right, it's going to use the same scale factor. So you would take whatever the original perimeter is, you're going to multiply by the scale factor. For example, if the original perimeter is 20 and the scale factor is 3, then the new perimeter would be 20 times 3, which is 60. That would be the new perimeter. The perimeter uses the same scale factor. All right, now the area. You've already seen 2 examples. The area is not the same scale factor. It's related, but it's not the same. So I'm just going to show you why. If you have a rectangle, and let's go back to that very first one where we doubled the dimensions, okay? I'm just making up different dimensions. Let's just say this was 4 and this was 5. The area would be 20 because 4 times 5 is 20. If I wanted to double the dimensions, this dimension would be 8 and this dimension would be 10. My new area would be 80. Now, you can't just do 20 times 2 and get 80. The scale factor was 2, but because I multiplied this dimension by 2 and I multiplied this dimension by 2, I multiplied 2 dimensions. So that means it's the scale factor squared. So let me show you what I mean. Right here, the scale factor was 2. But the scale factor squared. You have to square whatever the scale factor is, you have to square it. And 2 squared is 4. That's why it was 4 times as much, because I've multiplied the length and the width. I've multiplied 2 different dimensions, and then I'm multiplying those to find the area. Perimeter, you're just adding the sides. So everything is staying the same, but because you're multiplying the width and the length, and you've already multiplied those already, then you're actually squaring the area, whatever the scale factor is. So let me show you. The new area is whatever the scale factor is squared. So let's write that. You have to square the scale factor. You have to square the scale factor. You have to get that down in your notes. So if the original area was 20, like here, and the scale factor was 2, because I just said we doubled it, we want to square the square factor. Square the scale factor. 2 squared is 4. Then we can multiply 20 times 4 and we can get 80. So the area is actually the scale factor squared. That is the relationship. The perimeter uses the same scale factor. The area, you square the scale factor. Okay, let me check the time. Oh, we're getting close to 15 minutes. Okay, I'm going to stop and then we will pick up at another time.